Hello, my name is Patience Raby, and I am presenting today with Angel Padilla. We are both students at the University of New Mexico. Our project is titled Cool and Sustainable Sidewalks and has been a collaboration between ourselves, Logan Hutchison, Amin Najrani, Amanda Baldridge, Edgar Hernandez, Michael Suarez, Matthew Ricks, Brittany Antonchak, and Stephen Montano. As you may be familiar, there is a major and commonplace problem across the country: subpar or untraversable sidewalks. Common causes can be expansion and cracking from changes in weather, uplift by tree roots, or simply cracking from improper installation methods. When sidewalks become obstructed, they become non-ADA compliant, difficult to use, and unattractive. Sidewalks can arguably be considered a neighborhood's lifeline, and as such should be given the proper consideration. We looked into the history of sidewalks as much as we could and came up largely empty-handed. It seemed that there was no good explanation for the use of standard concrete mixes in sidewalks, or even for the fact that they're typically 4 inches deep. Typical concrete mixes contain a large amount of cement, one of the most carbon-intensive materials used in construction. It's been shown to be the 3rd largest single source of pollution in the world. The other environmental concern here is the urban heat island effect, or UHI. This is the modern phenomena where built infrastructure in cities impacts their ambient temperature, raising concerns. As you can see here, Albuquerque is one of the cities most impacted by this. Concrete has a relatively high heat capacity, meaning it holds on to heat well and is a big contributor to the urban heat island. Our technical challenge is to design a sidewalk that can be built using recycled and less energy and carbon-intensive materials with the thinnest possible thickness, in order to reduce material use and limit heat storage capacity. By revisiting the materials and techniques that cities and towns use to build sidewalks, we believe it is possible to identify more durable, environmentally sustainable, and cost-effective approaches than are commonly used today.
The research plan for this project involves casting and testing a few different sustainable concrete mixes. One mix will use fly ash and recycled rubber to replace the Portland cement in the concrete, which is the most carbon intensive and least sustainable part of the standard concrete mix. Additionally, recycled fiber mesh reinforced concrete is explored, as shown in the image towards the bottom of the slide. This is used to produce concrete sidewalks with greater durability, so the sidewalks can be built both thinner and more sustainable. And finally, 3D printed concrete will be explored to create sidewalks with internal voids built through the thickness of the concrete to reduce thermal conductivity and their heat storage capacity. This is shown in the video to the right. 3D printing is also autonomous, so it can reduce labor costs and the possibility of human error. It also uses less material since we have these voids, which makes it more sustainable. Testing done to analyze and characterize these different mixes includes durability testing, rheology testing, structural testing, and thermal testing. The thermal testing is shown here. This is performed to quantify the thermal properties of the sidewalks and analyze their contribution to the heat island effect. Solar irradiance testing is used to determine how much radiation is reflected back out from these sidewalks. And then heat capacity testing using thermocouples at different levels in the concrete, as well as the ground beneath the sidewalk, is used to determine how much heat is being stored in the concrete throughout the day. Then these are combined to build a heat energy balance model that summarizes where the heat is going to be going throughout the course of an entire day. From this research, some anticipated conclusions include showing how the proposed concrete mixes will reduce carbon-intensive materials. Additionally, that by minimizing materials used, consumption of raw materials will be reduced, as well as cost and the intensity of the urban heat island effect. And finally, the final design will be more resistant to common environmental stresses like tree root rot, freeze-thaw cycles, and de-icing chemicals. Overall, our project seeks to improve the quality of people's lives, but by designing new materials and methods for constructing high-quality sidewalks in a more environmentally friendly, durable, and economically affordable manner than current construction approaches allow. That's all. Thank you for your time.